Hey guys, so in the last video, we talked about having a certain number of ratios of reactants to make a certain number of products. And in real life, we don't always have the perfect amount of reactants to react with one another. So we can make a certain amount of products, but that amount of product might be limited, and we might have an extra of one of the reactants left over. So before we look at this as far as a chemical reaction goes, this is a very simple analogy. So I want you to take a look at this picture. Look at how many hot dogs I have. Look at how many hot dog buns I have. How many sandwiches can we make? Is a hot dog a sandwich? I feel like that's like an ongoing argument. So we can make 4 because each hot dog gets a bun, right? Now, if I have 5 hot dogs, how come I can't make 5 sandwiches? Because my buns are limiting my output, right? If I make 4 sandwiches, what am I going to have excess of? I'm going to have excess hot dogs. And I know that you guys don't have this in your note packet. Or do you? Maybe you do. If you do, you can write it. So this is a very simple example. Now we're going to look at what this looks like in a chemical reaction. The giant red flag for knowing if it's a limiting reactant or a limiting reagent question is if they give you an amount for both reactants. If they give you an amount for both reactants and say, how much product can I make? You have to actually go through the mole conversions for both givens and then decide, okay, which one of these makes less reactants? That's the one that's going to limit me. That's the one I'm going to have to go by. So what does that look like? Here I have 48 grams of methane and 96 grams of oxygen, and they want to know how much carbon dioxide am I going to be able to make. If they're giving you both reactants, that's a red flag saying that these reactants we don't have the perfect amount of each to go together. So I have to figure out which one I have, which one is going to give me least product, and that's the one I'm going to have to go with. Before you start doing anything, your equation does have to be balanced. So I'm going to go ahead and do that quickly. Here we go. So now I know the mole ratio of reactants to products. Okay, so let's start by writing what I'm given. 48 grams of CH4. Now, I always want to convert everything to moles, right? So 1 mole of CH4 is 12, 13, 14, 15, 16 grams. And notice how, guys, I'm not only writing units now when I'm doing my dimensional analysis, but I'm also writing what substance I'm talking about. Because now the question wants to know about CO2, and I'm given information on CH4. So now I have to use the coefficients in my reaction to say, all right, well, for every 1 mole of CH4, I'm going to be able to make 1 mole of CO2. And this is from the other video. I got those numbers by looking at what the coefficients are. Okay, so I'm going to stop here and I'm going to solve, and I'm going to get 3 moles of CO2. So that's how many moles of CO2 I can make with 48 grams of methane. Now let's see what oxygen is going to give me. So again, I want to convert this to moles. You always have to go through moles. Okay, all right, so now I have moles of oxygen. I want to see how many moles of carbon dioxide I can make. Now, oxygen, my coefficient is 2. So for every 2 moles of oxygen, I'm able to make 1 mole of CO2. Right? And if I do that calculation, I get 1.5 moles of CO2. So guys, whichever reactant you're given, whichever one makes the least amount of product, that's your limiting reagent. So oxygen is my limiting reagent here. It's like my hot dog bun. I can't make 3 moles of carbon dioxide because my amount of oxygen that I had to start with is going to limit me. I can only make 1.5 moles of carbon dioxide, and then I'm going to have leftover methane. methane is going to be my excess. All right. Now I can't stop here because the question didn't ask me how many moles of CO2. It asked me how many liters of CO2 is going to be made. So I have to do one more step. If I have 1 mole of a gas, that's going to take up 22.4 liters of space. And my final answer is going to be 33.6 liters of CO2. Okay, so that's my limiting reagent. I want you guys to try the next one on your own. I want you to balance it. And then I want you to do the same thing I did. Given both reactants, I'll start it for you right here. I want you to change them both to moles and then change them both to moles of NH3. And I want you to figure out what the limiting reagent is. That's going to be your first question. Okay, so hopefully you got that right. I'm going to go over it if you didn't. First, it has to be balanced. 1 mole of N2 is 28 grams. And for every 1 mole of N2 in the reaction, I get 2 moles of NH3. 3 moles of NH3. Okay, now what if I have hydrogen? For 1 mole of hydrogen, I have 2 grams of hydrogen. Be careful, guys, because these are diatomics. Now, if you look in your reaction, it's every 3 moles of hydrogen makes 2 moles of NH3. And I'm getting that from my coefficients. And when I calculate, I get 2.7 moles of NH3. So you should have answered that hydrogen is your limiting reagent because it makes less product than the nitrogen does. Okay, now I want you to go ahead and actually answer the question. The question doesn't ask for moles of NH3, it asks for grams. So can you guys go ahead and do that calculation? Okay, and you should get that as your answer. All right. Now, guys, this last one, they didn't ask us this in my first example, so I'm going to do it with you. These last 2 steps, because I just wrote out the steps for you down here, tells you how to calculate if they ask you about how much excess product remains, how much is left over. Like with my hot dog buns, that would be like me asking you, how many hot dogs are left over that you couldn't form a sandwich with? And the answer would be 1. It's a little more complicated, obviously, with a chemical reaction. So what you have to do is you have to subtract. It says subtract the moles of limiting reagent and the moles of excess. So I'm just taking my 3 moles and I'm subtracting 2.7 and I get 0.3 moles of NH3, right? And then they want to know about the reactant, how much of the reactant is left over. So I have 2 reactants here. I have hydrogen and I have nitrogen. If hydrogen was my limiting reagent, then all of the hydrogen reacted, the same as my hot dogs were my limited ingredient. So my hot dog buns were my limited ingredient. So I used them all. Hydrogen here was my limiting reagent, so I used it all. So I'm going to have 0 grams of hydrogen left over. That's going to be part 1 of my answer. With this, I want to figure out, okay, well, my other reactant was nitrogen. How much was left over? So I have to go back to reactants. I have to say, okay, I have 2 moles of NH3 for every 1 mole of nitrogen. Right? I used the coefficients in the reaction to do that. But now they don't want to know moles of nitrogen, they want to know grams. So for 1 mole of nitrogen, I have 28 grams. Okay, and if you solve that, you get 4.2 grams of N2 going to be left over. All right. All right. Last thing, guys, is percent yield, which compares the amount of product you actually make. This is from an experiment or from a lab that you actually do to the theoretical yield, which is you doing stoichiometry. So you can calculate what you should get, but then when you actually do the experiment, we rarely get what you're supposed to. Okay, so for a balanced equation shown below, if the reaction of 20.7 grams of calcium carbonate produces 6.81 grams of calcium oxide, what is the percent yield? So guys, this is the actual. When the student did the experiment, this is how much calcium oxide they actually got. So that's going to be our top number. But we need to figure out, if I started with this much calcium carbonate, how much calcium oxide should I have been able to make? So 20.7 grams of calcium carbonate. Let's change it to moles. 1 mole of calcium carbonate. Now I want to go to my periodic table. 40 plus 12 plus 48. 1 mole of that weighs 100 grams. Right? Now I want to say, all right, well, I have 1 mole of calcium carbonate in my reaction, and I have 1 mole of calcium oxide in my reaction. And now I want to know how many grams that's going to be. So if I have 1 mole of calcium oxide, that's going to be 40 plus 16 is 56 grams. And if I multiply across and then divide by 100, I get 11.592 grams of calcium oxide. So if none of my reactants or products were lost, I should have been able to make 11.592 grams of CaO, and I only made 6.81 grams, right? So this is my theoretical. And this is why in every lab, guys, we talk about error at the end and what could have made our experiment better. We're always gonna lose some sort of reactant or product for whatever reason, okay? So percent yield, I'm gonna take my actual over my theoretical times 100, and I get 58.8%. Okay, so I'm going to let you guys give one a try, and then we'll spend time practicing in class tomorrow. Have a good day.